So we draw the end circles of ABM and ACM. And we draw the points of tangency. So D and E are the 2 points of tangency with BC. And then, wait a sec. Oh no, AB and AC, sorry. And then we draw the point such that DMEF is a parallelogram. So one way to do that is to draw the midpoint of DE and then reflect M across it. Let me make it so that, trying to think of a good way to draw it. Yeah, I don't want F to look like it lies on those two circles. Just do it like that. I'm going to reflect M across F. So, it's hard to make it look good, but you guys know what I mean. So we want to show M prime lies on the bisector of angle A. You could just hide that for now. So this is I'll call it F, just because that's what it is in the problem statement. I wonder if it would help if we drew the point. You know the trick that I was telling Rodrigo? Is Rodrigo still on? Let me check. I don't think Rodrigo's still on. But I was telling him a trick to solve a different problem that he mentioned earlier.
Yeah, I remember.
Yeah, maybe we can make a parallelogram. So let's see. And then we could try doing the same thing. So we could draw the end circles of BCM and CGM. All right. So these would be the points of tangency. Is EM and H collinear? I think EM and H and DM and I are collinear by symmetry. And triangle DBH is congruent to triangle ECI. So DHIE is a parallelogram. So if F lies on the bisector of angle BAC, I think that means that the triangle ABJ would be isosceles. Yes.
Can you draw in the incenter of ABC?
Yes. Sorry. So yeah, I could hide the in circle, but yeah, we could show AF and J are collinear. Maybe I should draw the other two centers of the in circles, because basically they have to be collinear with BJ and CJ, right? So so BK and J are collinear, JL and C are collinear. Let's see. Sorry. So I wonder if I could take a homothency. What if I reflect A across the midpoint of DE? Let me see what that might do. Reflect. I don't know. I don't know if that really does much. So let me try something. Basically, we want to show DN is parallel to AJ or AF. Let's see. So that's the same as showing AF is the angle bisector of DAE. This looks sort of familiar. So I wonder if there's something like with spiral similarities. I'm just trying to think. So I feel like I'm thinking trigonometrically. So maybe like we have sine BAF over DF is sine EAF over EF. And then we have sine, no, I'm sorry, sine BAF over DF is sine ADF over AF. And then we can do the same with triangle AEF. And then maybe we could also do a similar idea. Just thinking. I feel like there might be a way to bash it with law of sines. Yeah, I wonder if there's a more elegant way. So or maybe we could draw the circumcircle of ABC and we could take the midpoint of arc BC and show that AF is collinear with that point. That might help. I'm going to try that. Let me delete a couple things that I added to the figure. So I want to take the midpoint of arc BC. Call it G. I want to show that AF and G are collinear. We know AJ and G are collinear. And we know GM is perpendicular to BC. So yeah, it's like if we draw, I could almost hide point F for now. It's like if we draw AJG, we want to show that the point making a parallelogram with BME lies on that bisector. Just going to draw it in just for the heck of it. It's like a concurrence problem. Yeah, we haven't used that D and E are the points of tangent C. But basically BB, it's half of AB plus BM minus AM. See you later, Rom. Have a good night. Thanks. Okay. This is tricky. So yeah, could we bash this using law of sines? I wonder. Hide that. Sine ADF. I kind of wonder what if. Sorry. There's got to be a better way. Like, what if I drew this circle? So G is the circumcenter of BJC. So we want to show F lies on AG. And we can extend AB to meet the circle. So what's the midpoint of FM? I'll try this.
Maybe we can draw in the point on Fm for which Fp is equal to Bm.
Fp is equal to Bm?
The point P on line Fm for which Fp is equal to Bm.
Okay. I will try that. Let's see. In which direction? In the direction down here?
Yes.
Okay. Got this handy compass tool. Let's see. Let me try. It's a little tricky. Fp is equal to Bm. This is one of the few times where GeoGebra actually makes it harder because the lines are so close. If I make it like a really flat triangle, then that makes it easier. Then F lies outside the triangle, but maybe that might make it easier. So Fp is equal to Bm is what you're saying, right?
Yes. Now we created congruent triangles.
What are the congruent triangles?
Oh, I think we should not say P lies on Fm. My idea was to make DFP congruent to MCE, but then this position was wrong.
But it's interesting. DFP congruent to MCE. How do we use the parallel lines? Flux. So I remember there's a parallelogram isogonality lemma. You remember the problem I did with the Sharky Devil? And then someone posted a solution on AOPS where they had this parallelogram isogonality lemma. I'm trying to remember exactly what it was. I wonder if it might come in handy here. Let's see. So what if I draw the perpendicular from F to GM? Just thinking here. So what would that mean? So I guess another way we could think of it is that the altitudes from F to AB and AC are the same. I wonder if AFD is similar to another triangle. Like what if we want to show DAF as angle A over 2. Is AFD similar to GMA? No, I don't think that's true.
Maybe we can try something like moving LME to moving ME to DE, and then we know, and then we get a point L prime, and then we know L prime F is perpendicular to AC, and then maybe we can say something, but it's only an idea.
Let me try. Sorry, I just want to check out one thing before trying that.
But I think I have to go now.
Well, thanks for the help. Yeah, have a good rest of your day.
Yes, thanks, you too. Bye.
See you.
Bye-bye.
So Ted, you were the last one left. So today was a tricky one, a tricky day.
Last man standing.
What?
The last man standing.
Yeah, you're the last man standing. So yeah, I might do it for like a half hour more and then I'll stop. So yeah, you can stay as long as you like.
It's fine. It's fine.
All right. Yeah, so like we want to show AGH is similar to AFE. No, I'm not sure if that's true. I'm gonna go back a few steps. let's see. So if I reflect B, let me try something. Reflect B across DM. Yeah. Hmm. If angle BFC 90 degrees, that would be a big coincidence if that were true. Yeah. Hmm. So what can we say about AD over AE? I think there's some interesting theorem about parallelograms and cyclic quadrilaterals. Trying to remember it. So let me see if I can remember. I'm just going to draw a little mini diagram here. I wonder if maybe, yeah, I think RP prime and RP maybe are isogonal. Yeah. Yeah. I wonder if that lemma can be used. So in this configuration, RP prime and RP are isogonal. Could we use that here somehow? It's a very weird. So if we were to do that, let EM intersect AB at a point and let DM intersect AC at a point. Maybe this would be amazing if this works, but it would be awesome. Well, yeah, AF and AM aren't isogonal though. That's the problem. It's an interesting idea.
We could assume that point F actually lies on bisector of angle A. We would just need to prove that distance from a point F to AB is equal to distance F to AC.
Yeah. Well, if F does lie on the bisector, then we know that the distance from F to AB and AC are the same, right? What if I draw this parallel? What if I did this? I really like this lemma, but I don't think I can use it. Well, you never know. What if I did this? Let's see. Yeah, I want to find a point. I'm trying to use this lemma right here. Let me try something. This is like crazy, but I'm just gonna try it just because I'm in a crazy mood. uh, Yeah, so if I label this intersection point, then so angle ATF is 17 degrees, and angle ETM 28.2. What? Oh no, I want it to be AEG. So I want this circle to be AEG. Then if I take this point, so FTD is 34.6 and ETG is also 34.6. Okay, so are TD and M collinear? That looks like it might be true. You think TD and M are collinear? I think so.
It looks like that, yes.
All right. Whoops. So and then let me draw TF. Basically, by this lemma, well, I'd have angle ATF is equal to angle ETG, basically. So that would mean let's see. I wonder if that means VMFU is cyclic. That doesn't look true. No. No, we would have to we want to see where ME meets TF. And we want to see where F we want to see where FE Now I'm thinking it might be like a special case of this. Yeah, so I wonder if showing P, D, and M is kind of enough, or collinear is like enough to solve the problem. Let me delete a couple things. So we have angle FAB is angle FTD is angle FTM. So we want to show angle FTM is A over 2. So yeah, let me check that. Yeah, I'm going to stop in about half an hour, but yeah, thanks for continuing. Maybe they're not equal. It shows they're different by like a 0.1 degrees. I'm actually not sure if they are collinear. It might just be really, really close.
Yeah, me neither.
Yeah, if I make like a really flat triangle, yeah, but then they're close to adding up to 90 because that's, if I have an acute triangle, I wonder if they're equal. It seems crazy that they could be that close but not the same, right? But I guess if I make it like a really narrow triangle, then they start to be different. Yeah, it looks like they're just really close but not necessarily equal. All right, I'm just going to delete all this stuff. I'm not sure how helpful it really is. I was just having fun with it. All right. Let's see if there's another way to think about this.
What was the name of that lemma from the right side?
Oh, I'm not even sure. I've just seen it before. I think it was used to solve an IMO problem, just like a cyclic quad isogonality lemma. Yeah, I don't know. But I think it's a degenerate case of the isogonal line lemma. So have you seen the isogonal line lemma on my channel?
I have not.
Yeah, so there's this other lemma called the isogonal line lemma, which is really useful. And this is like you could apply it to solve this problem, but yeah, why not? I'll just show it to you really quick. So it's pretty useful. So I'll show you. So let's say these let's say angle I H prime O is equal to angle N H prime P. So if these two angles are equal, so they're both 22.7, then what we can do is if you take these lines and they intersect at a point, and then you take these lines and they intersect at a point, then we have angle IH prime R is equal to angle NH prime Q. And it comes in handy a lot. So, so then that's 33.5 IH prime R, and NH prime O is also 33.5. So yeah, I have a video on this on my channel, but it comes in handy a lot. Isn't that cool?
Yeah.
There was 1 week where I used this lemma like 5 times in 1 week. But yeah.
Wow.
Yeah. Yeah, unfortunately, I haven't been doing as much lately just because I've been busier. But let's see. I feel like I might have even seen this problem before, but I just don't remember how I did it. Or it was like a long time ago. Yeah, it's hard to know which competitions are going to be hard and which are going to be easier, like when I pick the problems. But this was a tricky day. So let's see. The G is obviously the circumcenter of BJC. I feel like there's got to be some similar triangles that we create using these parallel lines. So Yeah, I'm thinking a lot of signs might be useful because sine DAF over DF is sine ADF over AF. Yeah, basically we want to show, I think we want to show the ratio of sine ADF to AEF is the same as the ratio of sine BDM to CEM. If you use the law of sines a whole bunch of times. Right, I'm gonna work on this like 15 more minutes. Maybe we could like use the radical axis theorem. We want to show DJ and the parallels. Let me extend these two parallels to meet BC. We want to show ID, NE, and GJ concur. Maybe they're cyclic. No. But yeah, maybe I could create some kind of like yeah, I'm trying to force the radical axis theorem here. Can I show GJ? What if I draw the circumcircle? Of GJ. And then I could try GJE. Let's see. I could let it intersect at another point. So we want to show, let me delete this. So I want to show ODEP is cyclic. Yeah, can I show OD EP is cyclic? That doesn't look so easy, but let's see. I think it's unlikely that that would work. It just seems like a tricky approach. Let's see. So what does it mean for a point F to lie on the angle bisector? It means the perpendiculars from F to the two sides are equal.
Yes, and perpendicular.
So what do we know? So this is like a line. This is like a segment from a vertex to the point of tangency. I feel like let's see, maybe we could use like the draw on this point right here. So if we label the midpoint of AB, let's try this. Then IK bisects MB. Let me try a whole bunch of different things. What if I did this? I'm going to try to do a homothency at point A. So I wonder if these are concurrent. What's that going to do? Wait, that's weird. I thought they would concur. Oh, wait, never mind. what if we draw the point such that FJM in that point is a parallelogram? What if I'm going to try just a bunch of them. So if G, F, and A are collinear, I wonder if we can say something symmetrically about we reflect F across. Let's see. And no, this is a tricky one. So I think I'll end it here. But yeah, for any of you viewing, if you have a solution to this, feel free to post it either on YouTube or on the Discord channel. So thanks, Matej, for participating. It was a lot of fun, and I hope you all have a good rest of your day. See you, Matej.
Thank you so much.
Have a good one. You're very welcome. See you.
Bye. Bye-bye.